Okay, we are live. Hello, everyone. This is Postgres TV Open Talks series, and with great pleasure, I'm presenting our today guest, Andrey Borodin. Hello, Andrey.
Hi, everyone. Hi, Nick.
So, Andrey is you have Ph.D. in computer science, right?
And yeah, that's true.
Right, and you
in analytical systems, but not in
analytical
transactional systems.
Okay. And you also I've checked your history of contributions to Postgres since Postgres 10. You are constantly
Correct.
in the list, right? And it always most of them are related to indexes, right?
That's true. My PhD was about OLTP indexes, and I've moved to Postgres to use my prior knowledge in Postgres.
So is B3 a very simple thing, or is it not simple at all? What do you think?
Yes, B3 is the only index that is learned in universities, and it's one of the most complicated parts of Postgres. It's there is a lot of stuff that details really matter, and I don't think there is more than maybe 10 or so hackers who understand B3 to the depths to each byte.
Right. It's good. It's good that I know you, and thank you for all your help. You usually.
My pleasure.
Right. So I appreciate that. Anytime I ask you something, you go very deep and explain me all the details. It's very good. And today we have open talk session. As usually we have only a few online viewers. Most of people watch us recorded. Those who watch online, of course, are able to use our chat and ask questions. This is good. Very good opportunity, but also it's possible to ask questions afterwards. If you watch a recorded video, feel free to ask questions in comments. We will monitor them. And of course, as usual, ask everyone to subscribe, like, and especially share the link in your social networks, in groups where you discuss Postgres and engineering questions and so on. Let's proceed. Today we have two talks. As I've said, for the price of just one, and the price is subscription to the channel. So, right. Let's start with what? With corruption or sharding?
Let's start with sharding. It's kind let's just start with it.
Let's just start and see how it goes.
Yeah. Let me share a screen. Here is my. Do you see it?
Yep, I see it.
Great. So I want to introduce you to SPQR. This is a tool that we are working on it to make sharding of Postgres easy, and it is currently under active development and active design. We would like everyone to join us in shaping how it works and what it is, because we want to make a very simple tool to solve very complicated and very hard problem. Basically, this is the SPQR team now, and also Artyom must be here, and Nick, of course, must be here too. But you see him online
somewhere behind this background.
yeah, and it would be great if everyone who is looking, who sees us now, would join us too. Any new service, any new internet service is kind of a startup which is growing fast, but everyone wants to be huge as Facebook are, or maybe as Gmail are, or something like that. Everyone hopes to scale exponentially, and sometimes you see that Postgres have some limits of data which can be served on one cluster. Typically, it's something of few terabytes and something of maybe hundreds of thousands of queries per second. And as it's obvious that, for example, Facebook is much bigger in terms of load. And we want to make a tool that makes this ceiling easy to go through and to grow through the limits of few terabytes in one installation of Postgres. What do we want from sharding? Typical installation of production Postgres is a very sophisticated system. Typically, it's high load cluster, highly available cluster based on physical replication. Sometimes it's shipping its information via some CTC system to analytical system to keep only operational data within transactional database. Most of the time you have some point-in-time recovery stuff, and it's already distributed system to allow cheap read-only queries, but all the writes still go to the primary node, which have maybe big capabilities, but still limited somewhere capabilities of writing queries per second. From the bird's eye view, we can see application like number of pods or number of virtual machines running with stateless backend and using a database as its stateful representation. We want to make smooth transition from one database to somehow many databases, many instances of Postgres clusters, but everything must be the same as it was before the transition. We want to solve the problem of this question. As we understand that each computational device provides a spectrum of different resources, CPUs, memory, networks, and block storage throughput and block storage latencies. And to efficiently utilize, we must make a sharding system that can operate on non-coherent, on different nodes and on clusters that provide different resources, different computational resources. And solving this problem could also help to solve a problem of migration data between clouds. So you can define some shards on premise and some shards in the cloud, and then ask the system to gradually move the data between locations. To do this, we must be able to slice data on some sharding key. And strongest assumptions that we take that data within one sharding key do not interact with data with other sharding key. And this raises a question of metadata granularity. We can keep ranges of data together, or we can address each individual key on its own. And actually, this question defines how many shards we can have in a system. And thinking about it more, we decided that we aim to something about 1,000 shards or 1,337 shards, because if we pick this funny number, we can aim at a router which have no more than a few gigabytes of random access memory to keep routing information where each sharding key lives on which shard. So that was our initial considerations. What we tried to make some simple sharding solution. First, we tried to use foreign data wrappers, and we created custom foreign data wrapper that was reading sharding key from a query already parsed by Postgres, and then routing the query to, it was made from Postgres for FDW, and it didn't work well because foreign data wrappers live in an assumption that all other tables are on the source cluster, that data is almost here and only one small table is somewhere at the other, on the other node. Yeah.
Is it okay if I interrupt and ask some questions?
Yeah, sure.
This is very interesting, because this is like common idea in Postgres community that we improve foreign data wrappers, we improve partitioning, and in future these two things combined will give us sharding automatically, right? So, and you say that there are obstacles that prevent.
Yeah. Nature of foreign data wrappers increase latencies of queries dramatically. Typical queries from sub-millisecond go to tens of milliseconds when they are routed through foreign data wrappers and partitioning. Eventually, when we work a lot on partitioning and work a lot on foreign data wrappers, maybe they will be good enough to do sharding.
So it's not a dead end. There are chances to...
I can't prove that it's dead end, and I can't prove that it's not. So I really hope it's not, because a lot of efforts of community is put into foreign data-based wrappers. But what I am almost certain that it won't be there today. It won't be there this year, and I really hope that it will be there maybe in 5 years or so.
Eventually.
If you want to handle a load of few million queries per second, even few million queries, not saying 10 million or 100 million queries per second, today you have to pick something like application-side sharding. You can't use
application-side sharding is term I'm using, and other people don't use it because if you check abbreviation, it's not good. Application-side sharding.
And how to say it?
It's because like it's some not good word if you pick first letters. I'm joking. Application side.
Yeah.
So people say application level sharding and so on, but I prefer right.
Okay, application level sharding.
Yeah, to emphasize the idea that we do need some common tool to avoid each team to implement it every time on application side. I use this term on purpose, but it's not good actually. Right. Okay, it was off topic. Let's yeah. Okay, thank you for.
By the way, the things that we call stuff really matters, because names in config file really define how is it to understand, how is it to set up, and we have a really I don't know how to say hard quarrels here how to call the stuff in config file, because it must be easy to understand, but every hacker is different. Everyone understand differently those config.
We all know there are two biggest problems in computer science: caching validation and naming, right? So it's true.
Yeah, picking correct names and idiomatic names and known to each other names. It's hard. Okay, so let's move on.
Thanks.
After foreign data wrapper, we tried to make custom planning node, Citus-like approach, and it didn't work well for us because database checks a lot of stuff instead of routing. It checks that all your invariants are correct in the query, that you are using operators that are defined, that you are using objects from actual system catalog snapshot, and on and on and on, and with a sophisticated system of caches and cache invalidations. And you don't need this stuff. You need just take a query and pass it somewhere and make it fast. That's why idea of stateless router was born, and we want stateless router, and we understood that it looks very much like connection puller, but we wanted to make a prototype that could allow us to fine-tune concepts and ideas that we want to implement. That's how we got Stateless Postgres query router, SPQR for short. It's a Go program that must work something like that. When you can define a column, you can define the ranges and map ranges of this column to some sharding key range ID. And when you are executed simple query, we just parse values and pass it to some shards. And as I said before, we understood that a router looks very much like transactional connection pooler, because at the beginning of transaction, we must find first query that can be routed to some shard. If it can't be routed to one shard, we must give an error. And then to the end of the query, we connect the client with a specific shard to work there. And here is an example when we insert values on one shard and looking for values that might be on other and don't see it. It is a problem for our approach, but we understand this, and this is by design. By the way, currently there is development very similar solution, which is called PGCAT. It is by design a connection pooler, which is very resemblant to PGBouncer, but there is explicit routing where you have to say that you want this session or this transaction to be mapped to some specific shard, and this makes impossible to implement our idea of simple sharding of existing application. I understand that this might be too ambitious idea, but still we want implicit sharding when we understand where the query must be routed on our own within our program. Soon we understood that a router is single point of failure, so we must have many routers to be able to handle some virtual machines fault failures. And if we have many routers, we need something that coordinates these routers. And this is where our name is not correct, because coordinator is stateful system. Coordinator is a system which stores metadata in so-called QDB. Currently it is etcd, but we can abstract it anywhere and even store metadata in Postgres. Basically, QDB is information which key ranges are mapped to what shard, to which shard. Yeah. And coordinator is responsible for creating new routers and moving data between shards. To move some data from one shard to another, we must inform each router that this key range is blocked, wait for each transaction with this data to finish, and then move the data from one shard to another and inform each router, go ahead, this range is unlocked. This is how it should work, and almost like it works now. We were thinking for a long time about how to split the data, and the traditional approach is that you can split data online using logical replication. We made few experiments and decided not to use logical replication to copy data. We decided that we will use just usual copy. But
why?
Because current implementation of logical replication is slow, and we can have a lot of simultaneous moves of key ranges. And for each move of key range, we must start our own val sender. Val sender will scan all val, and it's just too resource consuming. We decided,
and also it's single-threaded, so it only can grow. It has capacity. It can saturate on single CPU core, while sender can saturate it. And
yes.
To be fair, it's slow at your scale you're dealing with, but for many people it's okay. I mean, it has.
That's true.
It's like PG Bouncer until like 10 or 15,000 transactions before sorry use port was implemented. It was fine, but there is certain limit you can reach, and it's painful, right?
Yes, and it's not about a big scale actually. It's about
the speed of processing.
No, it's about using all resources of a typical virtual machine. So if you have a 32 cores virtual machine and you have maybe 32 val senders in progress, 32 transfers in progress, you can saturate all its CPU with just transfers.
This doesn't scale, so all 32 will need to scan all records on wall. This is like maybe one of the biggest problems. We had Amit Kapila a couple of months ago on Postgres TV. We discussed this topic included. So like logical is being developed quite well, like new features in each major release, but still I probably agree with you, there are issues.
Yeah, and we want to support Postgres 10 or maybe Postgres 11, something like that. Currently,
but in future it might change as well. Like if logical improves, probably it will be good here as well.
Yeah, currently we are using simple epsilon split. We are picking very small key range ID, key range, and just lock it through the whole movement. No writing transaction can be executed at this moment.
So only a few users can notice this problem. Like the idea is that
the idea is not that there is a few data. There is the idea that it's fast to move this data. Only few queries will get delayed, and they won't be delayed for long. They will be delayed for milliseconds. Maybe tens of milliseconds, maybe hundreds of milliseconds, but sub-second, less than 1 second. That's the idea. And we want to, this part is not implemented yet, we want to measure capacity of, we want to measure resource usage of each query by extension, which is called PG comment stats. But we can take the routing information not from actually comments, but from sharding key, and measure workload disk usage, CPU usage, and network usage, and balance each shard with its capacity. And usually we are asking the question, what if the query cannot be executed on one shard? Currently, we want to just throw an error, like, no, sorry, it won't be executed. But at one point, we will need to fall back to some system that can execute multi-shard transaction. We are considering 3 ways to do this. First one, Vitess-like way, like implement queries on our own. For example, union of many selects, it's easy, but group by is more difficult, and join is very difficult.
And data modification is even more difficult because it requires 2PC to be involved, right?
So our second option is to use world shard based on foreign data wrappers and partitioning, like usual Postgres way to handle sharding. but only for those queries that cannot be executed on one shard. So we will fast at throwing small queries at shards, and if you want something more complex, it will be executed on world shard based on FDW. And the third option,
sorry for interrupting. Have you considered PL proxy or in this place or no?
Not yet. As far as I know, PL proxy is based on procedures, stored procedures. And,
right.
You have to describe every query. If so, we could just give a user a shard connection strings and let they decide how to handle this query. But we want to be slightly more developer friendly than
right. The proxy is a great thing, but it's very limited to only those who are ready to use the procedures.
Well, its limits really help developers to shape their code to adhere sharding necessities. So it's limited in a way that makes sharding easier. Okay, let's move. Third option is just use Citus. But we have a lot of incompatibilities with Citus currently, and this idea is not flying yet. So let's go further. Artyom Kartasov measured latency costs of SPQR, and currently we know that SPQR's latency overhead is sub-millisecond. It's not much worse than just having a PG bouncer. And this is kind of surprising. We even tried to compare SPQR serving as a connection pooler with Odyssey. And we found that in many workloads, it works comparable and sometimes even better than C-written program. It sounds strange, but yet numbers don't lie.
Strange because it's written in Go? You mean like it should be slow? Then
yes, we do not control syscalls. We do not control real network code, yet it works fine.
So it means that there is some room for optimization.
I think there is a room for optimization in PG Bouncer and in Odyssey. It's they both are well good, but maybe better.
Okay,
maybe better.
Interesting. And it would be interesting to compare, of course, with Citus itself as well, right? Here in this table, like pgcat is written in Rust.
We tried Citus and we tried not current Citus. We tried maybe 8 or 9 months ago Citus, and it was adding significant overhead. We tried Citus, latency overhead, and we tried Citus on TPCC benchmarks before we even started SPQR. We tried it against CustomNode, and it was performing not very good on OLTP workload. Citus is really great at analytical workloads and at small writes, but at moderate selects, it showed not. Maybe we just used it wrong.
Exactly. This is what I wanted to say. This is key. Like for sharding solution for OLTP, latency overhead, and I wanted to have to do disclaimer here because we participated, Postgres participated. You mentioned Artyom in this benchmark. This was very basic PG benchmark. Disclaimer is it's very immature with research, so it was very basic. There is big room for maybe and even actually Marcus Slot mentioned something I did wrong when I checked Citus last time. It was a couple of years ago, and I didn't proceed. So probably we should go deeper, understand overheads of all systems better, and do better research here, because we like say, oh, this is worse than that. Maybe it's not that, because we didn't spend enough efforts here. So disclaimer is, don't think it's final result. It's some internal things we did for our.
This is always just a research. We are just looking for good concept for easy sharding, and maybe we are completely wrong.
I wanted to raise this in the very beginning, but I cannot. I need to raise it right now. Why, why do we do this? Why we just don't use Citus? Is it because of latency overhead or something else? Because maybe like when you started do this, implement this project, Citus was not providing all features in open source.
Yes, it wasn't full open source. Now,
right now
Citus is
changed.
Fully open source, and this is just so big improvement over what we were testing. And it's not even technical. It's about how do you think about the project? It was like some project made by Microsoft, and maybe we know Microsoft for years and for decades. But now we see that this fully open source stuff that we can trust, and this changes a lot. But we already in research.
This benchmark was done before they open sourced it. So my question is, like, if we find that we deal with Citus in the wrong way, and latency is indeed, I would say sub millisecond. We need sub millisecond latency at the scale like thousands of TPS at least. If it can do that, maybe this project should be closed, no? Like this is like the question to the heart, actually. But we need to compare, and maybe someone can, like, watching this can help.
It's not just about numbers. It's about defining simplest structure. Citus is big system. Citus is difficult system. Yes, it's hard to set up Citus. And
PGCat is very simple, but it requires explicit, like, it's very simple. I like it, like very, like, it's just one man doing it at wickets.
There is a lot of contributors, so I just check it, and there are at least 2 active contributors in PGCat.
Okay, it should change, the interest grows, right. But it's just a set of some baby steps leading to quite good result, and some projects I think can benefit from it, because it's like just like maybe explicit way of dealing with sharding is good, but we want implicit way, right? So we want more applications.
We want implicit, and we want coordinated. PGCat is standalone. It's not a group of routers that are coordinated. It's not moving your data. It's not balancing your data according to power of your fleet. It's just router. We have router in the name, but we are not just router, and we are not stateless. And it's not about query about transactions. Stateless. It's about Postgres. We have one true letter.
Right.
Okay.
But it's what you tell. It's like it's semi jokes, right? Because like there is some. Like partially it's stateless, like
we have stateless parts, we have query parts, and
just for our for people who watch us to understand better, well, this is like also joking at ourselves, but stateless is there as well, right? So
yes, the part which decides where the current query go is completely stateless. It can be totally rebuilt by coordinator.
We can use like 10 VMs running this router, right? This is
the basic idea. It's easy to scale. It's easy to scale, and it works without consulting with whole system catalog. The thing is, a lot of stuff is changed in system catalog, which causes a lot of sharding validations. And this problem will affect Citus too, by the way. They have to consult with system catalog, and that's why I'm not entirely sure TPCC test will be good for them because there is a lot of temporary tables, and these temporary tables send shared invalidations and reset caches to other backends. In a router, you maybe don't have data here at all, so the catalog is not needed here because
catalog can be slow as well. It can be bloated. It can give overhead. Like a very small off topic. I will be short. When I first touched Postgres in 2005, probably or so, I created already like first social network in Russia. Was called Moy Krug, when sold to
I
Yandex.
was registered there.
Right. And it was first written on MySQL, but and in PHP. And I realized that I cannot work with MySQL, many reasons. Like because I also had good education in the area of databases, I could not deal with MySQL. And I in a couple of days I completely rewrote it to Postgres. And first things I saw that dealing with catalog is very slow compared to MySQL. So I needed to add a cache layer for catalog requests. Only this allows us to proceed. This was like biggest obstacle of migration to Postgres at that time. But it was very long ago. It was Postgres 8.1 probably, so very, very long ago. But dealing with catalog may add a lot of overhead. And we don't have it here, so we can scale better and so on. And stateless, scaling stateless apps is easy. Just add nodes and that's it. And reroute balance between them.
So we are stateless twice. No catalog, and just add as many routers as you want. Okay,
good.
We have a demo application, demonstration application. I'm not sure it's best possible demonstration application. Just one, Denis just decided that he wants to port his application to SPQR, and this is a RSS parser, which just stores and reads articles on primary keys, and it's stored along with SPQR currently. You can run this application. It have a P server and RSS parser. I don't know why there are two programs, because we just want simple programs that demonstrates how to shard, how to scale, and how to make it sharded. Building it, to run it, you need to configure, and to have a big installation, you can set up QDB with metadata. But to have a very small installation, you can just define it in config file, where you define connection strings to shards and rules, basic rules how to deal with connections. And we have an administrative console where you can connect with PSQL. It's not exactly SQL, but something like that. And there you can read metadata about shards, and you can create key ranges and map key ranges to shards. Here you see that we creating column ID, creating key range from 1 to 1 billion, and map it to shard 1. And we can list all key ranges. By the way, currently we don't support sharding on many keys in one table, as far as I know. We were discussing this feature previously, but it works. Yeah, it works already. So you can shard by one or two or many fields, probably. I didn't try it myself yet. So what else? Here is a simple data definition language. We create a table and it will distribute it among shards. And then when you write article number 1, 2, 3, 5, it will get shard 1, and article 2 billions, it will get to shard 2. and you can select, and here you see two somewhat incorrect results, because looking for articles where ID is greater than 1 cannot be executed on one server, strictly speaking. Yet currently it's routed to shard 1, and another search is routed to shard 2.
So we need to see two rows, not one, right?
Yeah, we must see 2 rows if it was executed on a single database.
Mm-hmm.
But instead, currently router find closest shard and select data out of the shard. I think we should fix this.
How?
And how? Just throw an error, say that define a range that strictly within one shard.
And in future, it will be possible to make it redirect, to have it redirected to this like world where Stateless awaits or FW awaits
yes.
It will be slow, but it will work, right? Okay.
True. That's true.
Good.
Some parts of application didn't work at all. For example, you just can't select all the data. And actually, this is a big problem for sharded databases, because you need some kind of consistent snapshot across different shards. Currently, this problem is not solved in mainstream Postgres 2. There was a patch with Clock CI by Stas Kelevich. This is an algorithm to make snapshot consistent across many Postgres nodes, but selecting everything with one snapshot is not possible in Postgres today. I'm not sure, does the site solve the problem of snapshot consistency? Probably no. Okay. So
right, but here I always tell people, mostly application engineers, that we almost always, very often, default level, isolation level is read committed, right?
Mm-hmm.
So inside one transaction, we deal with multiple snapshots as well. We select twice and we have different results. So it means that somehow the world lives with it.
Yeah, but
you can go up, but you have issues with scaling.
For example, if we are doing banking application and we want to know how much money do we have, and we want not select star, but select count star, sum star, sum monies, all the monies in every shard. If there are cross shard money movement, you just can't get
single query deals with several different snapshots, so we have wrong data actually.
And in banking, correctness is very important feature, which is there for one shard of Postgres, but for multi-shard Postgres, correctness is still hard to achieve. Okay, so we are open to any consideration. We would appreciate any ideas on how to make sharding simple. If you have the idea what to remove from our system and what should not be configured and should be strictly hard-coded in the system, please ping us on Telegram chat. We have a development chat to discuss this stuff, or maybe
we probably need to provide the link in description. I will put it to a description of video.
Great, thank you. Sure. It's easy to find us. SPQR is common abbreviation. Maybe it's not easy to find us on GitHub.
Right. Well, I will provide all links in the description under the video. Right. Speaking of name, we have a comment from Grigori in our chat that it's from ancient ages, this abbreviation, right? So.
Yeah, it's something about pizza, I think.
It's about what?
No, Just a joke.
It's yeah. Okay, I didn't get it. Okay, Senate and people of Rome. Okay.
Yes.
Good. Pull requests.
Pull request would be welcome.
I would emphasize that this is like it sounds to me the most interesting to compare and check research latency in other systems as well, because this should give the good answer. Like maybe we should just all use Citus, but the question is why we don't see big OLTP projects using Citus. I ask Citus guys all the time, like, where are these big projects, like scale of, like, I don't know, like Slack or some social.
If I would be a manager at Microsoft, I would just find some new service and say, hey, now you are using Citus. You just have to use Citus.
Right.
Or maybe find some already big, but not that big project and say that, like, you get 2 more headcounts if you 10 more headcounts if you go to Citus next year.
Right, but also a way. But maybe I'm ready to be wrong. If I see a good project, I will be the first who will start spreading the information about it in my Twitter and so on. But so far, I haven't seen very good, really purely OLTP example, not like HTAP example when people are ready to wait a couple of seconds when they do some searches. So
it was very important for us to just where is it? To make this decision. Where is it? Yeah, here. You see on the left, MapReduce or analytical system, that we don't want analytical queries to be run in our system, and this makes us free from a lot of technical stuff that we don't have to implement. And I think this road to separate analytics from operational data it's ancient. Actually, we can get a database book from, I don't know, from beginning of web era, and there is written that there are OLTP systems and OLAP systems, and I think this still holds true, and we have to separate these 2 kinds of systems.
Yeah, probably yes, right. And of course, analytical workloads are like much better executed on systems where there's a column store, and Postgres like still on its way to like have it internally easily without big overhead. It's possible, but
Citus have it.
Yeah, I know C-store, right? It's called right, C-store or something like this. But I haven't tried. My disclaimers, my checks are not complete. I need to try deeper and so on. So I wanted to emphasize that help is needed here. If someone is interested, please join and let's explore the things together. And of course, maybe Citus people will also say their words.
That would be great.
Right. Yeah. And I really like, it's so big news that Citus moved everything to open source. It's so cool. Like, it's a great move. So, and of course, Citus is a huge system. But let's see. I think Postgres needs also, like, I wanted to ask you your opinion. What do you think about just partitioning? Just like, Postgres limits are already too high. We have beefy servers these days, like hundreds of cores, especially if AMD, not Intel, and terabytes already of RAM, right? And very fast disks, like 2 gigs per second for reads and writes. It's already in clouds. It's already available. So why? And if we do partitioning to deal with long vacuum and slow reindexing and so on, like to limit, like rule of thumb is like if you have tables more than 100 gigs, use partitioning, like a must to have partitioning. Maybe sharding is not needed. We see people grow companies to multi-billion evaluation and so on, like just using single primary, right? It's possible.
Yes. I think that you start to need sharding only if you want that anyone in the world use your application. if you don't aim at be available to any human on the planet, probably you can go along with just Postgres.
It triggers another interesting question. Why we should shard at database level, not at application level? For example, if we think about the whole world, we can think about routing at application level and teach our independent applications, which each one having their own databases in each region, right? To speak at upper level, at application level, like at API level, not at data route up higher, right? In architecture. So it's also a valid approach, like it's a viable
absolutely
approach.
It's absolutely it's working. It is working. I think that maybe another example, if you have not really very clean data, for example, I'm not sure of, but for example, take Yandex Mail, if you take it, if you like. We have like 500 million or so mailboxes. I'm not working for mail, figures may be incorrect, but I suspect that there is a lot of spam. Just like most of these messages are spam. If we remove spam entirely and subscriptions entirely and notifications entirely, surely
ideal world, right?
Yeah, surely it would meet easily into one Postgres. But when we have this whole lot of junk, we need sharded Postgres to manage it. And other other examples are infrastructural services like S3, where you have a lot of chunks of other data, like billions of names of data chunks, and we need sharded system to hold this. Not applications side, application level sharding, but something that is automatically rebalanced. So maybe systems for systems need sharding still. Systems for people don't need sharding if you not aim at planet scale. Even if you aim at planet scale and can divide it in some regions, still you can avoid sharding.
Yeah, we wanted this talk to be 20 minutes only, but my questions probably inflated, right? So like two more questions. You touch on very interesting topics. One is if we think about rebalancing, I think like in a sharding system is routing is maybe easier problem. Rebalancing is a bigger problem, in my opinion, because if system provides good way to rebalance without downtime, this is a good system with sharding. It should provide it. And the idea of small chunks, you called it liquid data, right? So data is like liquid, like we just
floating through from one cloud provider to another cloud provider, from on-premise to. I know that there is a lot of people skeptical to moving data between clouds because of data gravity, but yeah.
Yes,
what was the question?
I'm stopping your sharing. Okay. Let's restart it again for a second talk. And like I also forgot to mention, we don't limit timing, so it's a very interesting talk. Why to limit it, right? So question is like it's not a question, it's a comment, right? So this liquid data is a very great thing, and probably it's more important than routing itself. And on application level, if you have sharding, you need to implement application level or like multi-region system. Each system is different. You need to implement how you move data between regions, right? So because you will need to also sometimes to migrate data and so on. It's hard problems to solve, and this system and Citus solves it, and this system probably will solve it successfully, and this is value it adds to developers, right? But you mentioned also PlanetScale, so I cannot avoid asking you about PlanetScale, the company, and the system. They, like the same people, also develop actively Vitess. So a few years ago, we talked with Sugu, the founder of PlanetScale, and we talked about the idea of implementation. This system is supporting only MySQL. Vitess supporting is only MySQL. And in MySQL world, this is the way to go if you need sharding. Many companies with big names use it. But in Postgres, we don't have such system, and we always feel like we need it. Why Vitess, like for Postgres path, like let's just implement support for Postgres inside Vitess, why it didn't work, in your opinion?
Because Vitess is just too complex. It is actually executing your queries. Vitess is doing some kind of joins, some kind of aggregations.
BTGate component, which is also router, does this, right? Interesting.
Yes, and that's why it MySQL is everywhere.
But the BTGate component is also router. I thought it's also stateless. You know it much better. Like, but it doesn't have MySQL inside. It doesn't have SQL inside.
MySQL is everywhere, but
okay.
At first we reused parser from Vitess. It's using, I just can't remember it now, some open source parser, and we use the same SQL parser as Vitess does. But besides this, we couldn't extract components that we could reuse from Vitess. So, it's big system.
And as I know, they postponed the plans. As a company, they decided at the end of the project, they decided they closed this issue on GitHub and said that if someone wants it, do it, we will consider pull requests, but we don't have it in the roadmap anymore. So it's interesting.
Vitess is solving some problems that are solved in Postgres world in another manner,
in different way.
In different ways. They, for example, they have a high availability stuff, which is incompatible with Postgres. I can't remember other examples, but they are there. We just solve same problem different way.
I see.
Than they do.
Interesting. Well, okay. Let's stop at his point because we have a second talk, and I hope people will follow up with questions and maybe participating actions, like do some research or coding. Like, this is interesting project. Okay. Second topic is index corruption and adventures. Right. So
just
this topic should be of interest for everyone who is dealing with Postgres in production.
I'm not sure. Like, Postgres is a reliable system. Oh, it's wrong. Not. Okay. Do I share correct screen now? Yeah. Corruption monitoring and emergency response. Like, when you're starting using Postgres, probably you don't need to worry a lot about corruption. But if you are using like petabytes or maybe even terabytes of Postgres, you just have to have a plan, like where to move and what to do if some kind of problems are encountered. At first, let's talk about easy way to get corrupted database. It's part of my previous presentation a few years ago, but still I will repeat it. Easiest way to get corrupted database is turn off fsync. If you are running a database with fsync off, probably it's dealing as a service. At some point, you can get corrupted database if you restart it, if the system reboots for some reason, something bad happens and just there is no data anymore. To let the Postgres be real database, enable async. Another costly option is full page writes. If you don't have full page writes and restart system often, you can get corrupted data, and when I'm saying corrupted data, it means you just can't select anything from a data from a table. You're running a query, and at some point, query is encountered broken page, and Postgres will refuse to give you incorrect result, and that means that basically all data is lost, and it's always unacceptable for a database.
This assumes that we are on file system like ext4, which uses 4K size for page block, or no? Because if we use, for example, ZFS and the record size is 8K.
If you have a block size of atomic write, well, you can run Postgres with different block sizes. Typically, it's 8 kilobytes.
On Postgres side, but file system typically is 4. Right?
Yeah,
that's why the full page writes are needed.
If your file system provides you atomic write of Postgres block, then full pages are unneeded.
Usually it's not so, right?
Yes, usually it's not so, and if you're using ext4, probably you have atomic write of one sector of 512 bytes.
Oh, okay. Okay. Thank you for clarification. Yep.
The data checksums hardware can be affected by cosmic rays, and to be sure that there are no bit flips within your data that is read from storage device, you have to make checksums on. Luckily, now in Postgres you can do it online without turning off your database. You can. I can't remember exact steps, but you can convert high available cluster from checksums off to checksums on.
Standby first and then perform switchover. Yeah. It's possible, and there is a way to do it for older Postgres clusters as well. It was backported by Cybertech, I guess, and there is it's all published on GitHub. Cool. And latest major versions of Postgres have these data checksums enabled, right, by default at NDB time. The problem is that it's not a setting in Postgres configuration file. It's what you need to do at initdb time. So that's why it's a problem, right? And I just trying to do some very basic things for those who watch us and try to understand them.
Yeah, thank you.
And also just a small comment. In WAL, checksums are present for many years, right? When WAL record is written, it's protected. So for WAL, we are on safe side. But data checksums, for if you created a cluster a few years ago, probably it's off. And this is okay. Sorry, let's proceed. Sorry.
Yeah, no problem. Well, cosmic rays are real. Every quarter of gigabyte experience 1 bit flip a year, according to researchers. So you don't see implications of these bit flips. For usual memory, it's just a reboot or something like that. But in databases, 1 bit flip can change everything. And bit flips in storage device are effectively prevented by data checksums. So real dangers when you configure everything right, but still you can have some corruption. Almost unreal stuff that happens from time to time. but you probably can read about this in newspapers, but not observe it on your systems. This is compiler bugs, CPU microcode bugs, and RAM corruption due to cosmic rays. Why the list is unreal when it's real? Just wrong category. So CPU bugs happens, and sometimes CPUs mangle data, but it rarely can be observed. Unlikely to happen, but still happen from time to time. Like DBA will see it once in his career, probably. Like file system bug or Linux kernel bug that is destroying his data on some occasions. I saw that we used for a time the special patched kernel version, which had a page cache bug. If you are using patched kernel, not official Linux kernel, this becomes much more probable. And then probable sources of corruption. Postgres bugs. It happens, and fix it. And usually we try to supply tools to fix those bugs. Still, sometimes in Postgres we encounter that something somewhere is broken. It's least probable in this list. Sometimes we get a storage device firmware bugs, and this happens like every year or so, maybe every some years, every 2. So it is happening, and you can have bugs in backup software. I have done one myself 4 years ago, and it was a difficult job to fix everything. We didn't have this bug in production, but we have this bug on all testing databases, and it was maybe a year of work to recover everything that was affected by very, very small off by one error in backup software. Like
it was in Volgy or
yes, it was in Volgy. There was a technology which is called Val Delta, which is making Delta backups based on reading Val, and it was missing one record, one Val record, and in some cases this resulted in one page change being undetected. This technology was enabled on testing for half a year, and then we found that some standbys have some wrong pages. We found the problem, fixed it, released the notes that previous version contained a bug that is corrupting. We never enabled it by default in Volgy, but still we had a program that was making corrupted restored standbys, and that's how most of our stuff was developed, because we needed to fix our testing databases. Okay, so signs of corruption. How do you know that something is corrupted? There are some obvious things that must be monitored on somehow. For example, if you have a core dump, if you have a segmentation violation, it's always a good thing to have a zigzag core dump monitoring and analyze each core dump. Typically, just backtrace is enough to understand what happened. Each backtrace of failed Postgres is of interest to hackers because sometimes bugs in Postgres happened, and we want to know how and why Postgres crashed.
But to get backtrace, you need to be prepared, right? So by default, default Postgres installation won't provide it to you, right?
I mean, yes, you need to install debug symbols.
Right. It's very recommended to have debug symbols installed everywhere. Like there's no big overhead.
I'm most of the time when I'm using debug symbols is when I see that quorum replication high cluster is have some lags in replication. First thing that I do is just get a backtrace of startup process and see where is it sleeping. So
or use perf. You can use perf.
No,
and
you
see.
don't see in perf things like conflict resolution. You don't see something like access exclusive logs are logged, well logged, and you may see that when on primary you have a lot of schema changes, they generate this access exclusive logs records in val, and on primary everything's fine, but on standby you see some lagging and where did it get from, and actually backtrace can help you see that there is a logs in val. So
anyway, you have debug symbols always installed, right?
Yeah, have debug symbols and be ready to get backtrace out of core dump. Other stuff, from my experience, is not very useful. Just get a backtrace. Backtrace is enough to say roughly about what was going on when the Postgres crashed. When you have indefinitely running query, you can get a backtrace too and see if it's reading the same block all over again. It means that there is a loop within an index, and probably this is a sign of corruption too. Some corruptions manifests as out of memory core dumps, and the problem of these core dumps that they allocate a lot of space, and the database can get exhausted of this quota. That's why they're dangerous. So just monitoring of free space will tell you that something is going wrong with out-of-memory allocations. And finally, it's hard to find. It typically backend engineers will tell you that different queries produce different plans. Same queries produce different plans, and these different plans have different results, but it's the plans of the same query. Typically, this is a kind of index corruption when the tuple can be found through index, but cannot be found. No, it cannot be found through index, but can be found with sequential scan or bitmap scan.
Or just they say, I know the result should be there, that some data should be in the result, but I don't see it, I don't understand why. Like users can tell this sometimes, and this is a sign of index corruption, right? It happened recently. Okay. Yeah. It's very common, I think.
True. Very common? What? No.
Index corruption is very common, especially because, as I learned not long ago, any OS upgrade, like Ubuntu upgrade or CentOS upgrade, when glibc version implicitly changes, any glibc upgrade is dangerous for Postgres. Not only some particular versions, but I will check all of them since then. Like.
Yes, but only if you are using non-standard characters. If you are English only,
well,
probably it will be fine.
Right. But if you're a global project, you probably already have everything inside your. So yeah.
If you have indexes over glibc managed collections, then you have to check every index and probably re-index after operation system upgrade.
During. because like this is very important in what I learned.
True.
You
can violate unique
look like the corruption which just returns the wrong result to user. It's one thing. It's just, I would say, like corruption and transfer, right? Like similar to security issues. So it's like encryption and transfer, so corruption and transfer. So data arrived, it's wrong, right? Okay, but if based on that data we saved something, it propagates to storage. It's already corruption in storage. It's much more. It hits even more. It will spread then, right? If we perform update based on this lookup using this corrupted index, this update saved the wrong data for us. And this is definitely what, like, if some user didn't find something, it's a big problem, but it's not the biggest problem. If we started to save wrong results, right?
I remember that one of the difficultest kinds of fixes of corruption was when the index was not, unique index was not finding the key, and the user was inserting again and again and again. And when I was trying to fix the database, I asked user which one
Stop
which one of these tuples must survive and others must be gone. He said, I know. I need all of them.
Yeah, why we discuss this? This shows that you cannot postpone the operation of reindexing after upgrade. You need to put it inside upgrade, and you need to make your maintenance window downtime bigger, or use some logical replication, for example. Again, back to logical replication question, and it means that it becomes a big task, because we need to index while users either don't work with our database or work in read-only mode. If you can afford the partial downtime, like tell your users read-only mode for a couple of hours, you can reindex and afford only corruption in transfer, not a corruption at rest, or like something like this. Like I feel this is like worth some research and also materials. We need more articles about it. This is a great material, and it affects many.
You can actually violate a lot, not just unique constraints, but some other, like you can, if you have a constraint that's
order by limit.
Yes.
Right. I recently learned on wiki page where like this problem is discussed briefly. Partitioning can be corrupted as well. If it's range partitions and this column which is used for range partitioning also can have character data, not ASCII only, right? Partitions after our upgrade of glibc can be affected.
And then reindexing won't help. You need to
it's a bigger problem. It's very rare, I think. Very rare, because usually people use like in numbers or Latin, like ASCII only. But it's we even didn't discuss this, right? So it's like there are things, there are so many corruption things. When you start working with it, it's like this is the same level of the same field in Postgres, like security. It's a huge field, and the corruption also is a huge field. Well, sorry, I'm inflating the talk again. Like let's proceed.
No problem. Typically, corruption can be observed within logs, and we put a lot of effort to scan through logs through non-typical messages within our log database. We have a ClickHouse for logs for Postgres logs, logsdb, and we scanned through logsdb and found non-typical errors. Go through the code and mark it every such message with special codes. There were a lot of special codes already, and we just found typical signs of corruption on our incidents. And now you can just grep logs for XX00, and if you see at least one, wake up SRE. There is just one case when this is not a data corruption is known tuple to be updated is committed, something like that.
I saw recently something related to replication, like wall record is behind or ahead of something. It was also XX000, the first one. It was not corruption, or like I don't remember, but it was not. It didn't look very dangerous to me. Okay, we can postpone this.
Okay, we monitor XX00 and pick up SRE. How do we monitor it? We have a corruption command which is executed every 2 minutes, and most important part of this command is that on thousands of clusters it will fail a lot due to out of memories, due to overload, due to some Python hiccups. And if the program didn't respond, it's just possibly okay. It's this little echo saves a lot of sleep time to SRE. What it does internally, it is scanned error codes for corruption. And to make scanning logs cheap, we implemented extension which is called log errors with system view pg log error stats. It's on GitHub, where you can get system view of errors that were in logs and get some aggregated statistics. But we are looking for each individual corruption record. This is how this extension look like. If we observe at least one record, we must do a scan of the whole cluster and scan for corruptions. And we do scan when the cluster is restored from backup. Maybe we are planning to do scan when the cluster is restored. When the user reports that there are some strange things with the SQL queries, and after upgrade or each failover. And as you correctly mentioned, on every upgrade of operational systems. And scanning system catalog is usually cheap and fast.
Hold on, one, like just to clarify, after each failover, you do what? You check what's happening on new primary.
I will. Next slide
okay.
is about corruption scan. It's not like index scan or bitmap scan, but everything like that. We have a small Python program which is doing just a check. It extracts all indexes that are not temporary and are ready and are valid, and do BT index check on every index. Some aspects of amcheck extension. This is an extension which is available from Postgres 10, as far as I remember, and it has two.
It had different name before. It was amcheck something before until some. Next. Yeah, maybe, but now it's called amcheck. I just, if you have old version, check slightly different name, but with amchecking it just to some tip.
Maybe.
Switch. Yep.
Maybe it wasn't in core before.
Maybe, yeah. Mm-hmm.
Peter Kagan is supporting his version, which is called amcheck next, which contain versions that he plans to get into the core.
Mm-hmm.
And if you want some cool new features from Peter, you can install his version of amcheck, which is cutting edge of checking technology. verification technology. Yeah. Basically, there are currently only two functions, first one is BT index check, which can be run on standby and do not interfere a lot with workloads. It's taking a small lock on a table. And interesting stuff is so-called heap all indexed parameter. If you're doing heap all indexed, it will get an index scan through the index and heap scan through the heap and compare each other that every heap tuple have a corresponding index tuple in an index. It doesn't consume a lot of memory. It uses Bloom filter to make it faster and less memory consuming. Parent check is only possible on primary. It will lock cluster from modifying table. That's why we rarely use it.
Exclusive lock, right?
Yeah, it's taking share lock. You can read your table when it's under check, but you can't modify it. You can't add new rows or update all rows.
Exclusive lock, not share lock. Or
no, it's share lock.
Okay, but with heap all indexed.
I have intentionally called previous lock like small lock, not with a technical term, because like technical terms are not easy to understand. It's share lock because like it's shared, you can read it, but you cannot modify it.
But as I remember, this second parameter heap all indexed, it also defined the severity of locking. No,
no, just a function name. Function index parent check is
heavier. It's heavy.
Takes heavier lock, but it is checking more invariants. It is
and it's very slower because of that, of course. It's very slower, right?
No,
no,
almost identical. It's the same code. For example, if you have two pages, first page is referencing second, and second is back referencing to third. And if these two links are not coherent,
corruption.
Parent check would complain because it have share lock and is sure that no one is modifying these pages. And first will complain too, but it wasn't complaining at first. But
it may be normal because without lock somebody is modifying, so maybe it's okay. We don't know,
and it will do some special stuff like look here and check, and look here again and check, and look here again and check, and say probably something is wrong.
But we're not sure. But when we have a lock, we're 100% sure that it's
amcheck is not reporting false positive. If amcheck is reporting error, it's there.
This is good to know. This is important.
Heap all indexed is 2 times more exhaustive, 2 times more work than just check without heap all indexes, all indexed. And root descent is a very exhaustive check. I rarely use it on production databases, and it tries to find each tuple from the root. It checks that each tuple in an index is accessible from a root page.
So a rule of thumb here is that the first function we can use right on production, right?
Yes.
And the second parameter of it will define how deep, like how like the duration of also, right? So if we use a true second parameter true, it will be longer, but we'll check it better.
Production, yes, but if you want to drop your table, first one will not allow you. For example, your workload may depend on creating new tables and dropping.
Oh, DDL. You mean if for example, deployment needs to happen and alter table also will be locked by the first one as well, right? So this is quite clear. Actually, any select will, if it lasts long, it won't allow you neither drop table or nor alter table. Even you cannot create column in your table if you have very long select. So it's fine. This is long select on our table. It's okay. This is clear.
Computationally, price of BT index check with heap will indexed true is almost equal to one full vacuum scan. Not vacuum full.
Regular vacuum.
Regular vacuum, but
not skipping frozen
without skipping pages. Yes. Okay.
And second cannot be used on production without downtime, without maintenance window, right? Because it will block your workload definitely.
Unless you have some unneeded table, maybe then you just don't need to check it.
Nobody is doing anything. Yeah,
if it's not used by anyone, so maybe it's not needed at all. Just drop the table.
But the first one is for production. Second function is for clones restored from backups and so on, right?
Yep.
Good.
Currently, amcheck only able to verify B3. I'm working on making a table to check gist and genes. But for gene, currently, I don't know how to implement heap indexed. Because gene, like in gist and in B3, each heap tuple have corresponding index tuple. But in gene, you can have entries and you have postings and you have posting list. And so I don't know how to do it, but working on this.
Yeah, we just yesterday we saw that this parameter doesn't exist. We used your patched version, backported it, and used it yesterday, and noticed there is no this parameter. So it means that we probably there are things we cannot check right now in gene indexes, and by default this is patched, right? So it's not released yet. So if you want it, you need to compile extension yourself, apply patch before it. Right, this is what we did. But it's good. It's good that there is some progress. So I hope it will be there soon.
There is quite old PG visibility, and in case of corruption of visibility map forks, it can help. And most helpful function is just to truncate visibility map. There is a function to just remove visibility map, and then next vacuum will rebuild visibility map. Currently, amcheck is not only extension; it's available as a separate binary to run executable binary to be run against a database and check everything in the database. If you're interested, check out the documentation page. We use so-called heap check, but it's not open sourced because it was replaced by available in amcheck verify heap am function, which allows you to scan through the heap and find some violation of invariants like exceeds not in expected ranges, or some unexpected virtual transactions, some unexpected multi-transactions, etc. And verify heap have a lot more parameters than index parameter. For example, it returns where exactly corruption is and can return you a lot of places where corruption happened, because you can just re-index heap. It's your data, you need to fix it one by one. And you have here a block from where to start and where to end. And there are different modes which can be specified in skip attribute here. good function. But in our production, we still use old heap check, which is almost identical code. We both took the code from vacuum to extension and made this function to check heap.
And this previous function, the verify. So this is additional extension which is like not included to core Postgres right now, right? So where can we find it?
Verify is in core Postgres from Postgres 13, I think.
So we just need to create this function to make it available in
amcheck,
SQL.
and it's already available. I've just didn't knew where to take and took it from source codes. But
so we can write this and in Postgres and it will work, right?
Just select from this function. It will check your.
It's already there.
It have almost the same prototype. You just specify name of your relation, and others just leave default.
Great.
It's very easy. It looks like there is a lot of parameters, but just the name of a table, and it will scan it.
Yeah, others are default, right?
Yeah. Tools to repair. The best tool
before
to repair
we go to
corruption.
the question, did you cover all kinds of corruption?
I don't know.
Because I think no, like the more we go deeper, we always find new horizons of corruption, right?
Yeah.
Also.
Sometimes corruption is that you don't have enough C-log files. It's the same version of
or very
high
level. Some like foreign key was broken due to one reason, Postgres bug, another reason it's propagated, and we don't have we have inconsistent data or unique key or something like that. There are many kinds of, right? Yeah, okay.
So it was all previous stuff. It was about how to do a scan if you suspect that something here is wrong, and you just use all this. Just use index check from amcheck, visibility check, and verify HIPAM. These three things help you to understand are there any problems actually in a cluster.
Do you need to do it only if you suspect this, or you should be paranoid all the time and do it regularly on
You do it after backup restore. You do it on user complaints, on your intuition,
switch over
after failover, yes, and upgrades.
Wow. That's a lot. So it should be a very good automated, I guess.
Yes, you need one shell script that runs all checks.
In parallel, because if you use, for example, amcheck, by default, it's not parallelized. And if you have a lot of indexes, of course, everyone has it. You want...
if it's not about seconds anyway, let it run through the day.
It depends. If it's not on production, probably single-threaded is fine because we don't want to overload it. But if it's a temporary instance in cloud and you pay for those hours, obviously, and you restored using parallel mode of OLG in 16 threads, you have 16 cores. Why then you use only one core when you do amcheck, right?
Yeah, I think.
So parallelization would be good here, and yeah, we do. Yeah. We already have something.
We use just sequential script, but I think you're right.
This is where we can contribute to community. We have a parallelized version in Bash actually, so I can share. It greatly speeds up the whole process. So good. Okay.
So tools to repair. Best tool to repair is your backup system. If you observe some problems, just make sure your data is available in a backup system. Unless the backup system is a source of corruption, of course. Then you need something better. Another tool to check out is pginspect and pghexedit, but this is a really complicated stuff. And just understanding tuple header from pginspect is difficult. You will have to know a lot about Postgres to understand what pginspect is showing you.
And it's also available only on Linux. This is the only reason latest years that I need a VM on my macOS to run pgxedit. Actually, unfortunately, it's working only on Linux. But it's good stuff from Peter Gagan, definitely.
Yeah. We have a extension which is called PG Dirty Hands, which can help with freezing problems. The problem can be why specifically for freezing? Because if you have for some reason violations between index pages, you can just reindex. If you have violations of constraints, you need to do something with data. But if you have contradiction between heap data and CLog, you need something to freeze or delete tuple, because you just can't delete corrupted tuple which have a wrong seed in its header. That's where freeze tuple or freeze tuple unlogged can help, but it's only usable for Postgres, for old version of Postgres. And currently there is a core solution which is called PG Surgery, which is doing exactly the same, but in core, and it's better supported than our Dirty Hands.
Is this also like an additional extension you need to have installed?
No, it goes with core.
Really? I missed it.
Yes, it's there unless you are on Postgres 12 or earlier. If so,
since
I
13.
can, yes, I can help you with backporting. I have a version compilable for Postgres 10, I think, or something like that. I just didn't put it on GitHub yet. But
and what does it do once again? Like,
if you have a tuple which you cannot read because its commit seed xmin or xmax are unavailable in CLog, you can say that freeze and let it exist, or freeze and kill tuple.
Freeze means like let's consider this from the past, basically.
Yeah, let's consider that seed happened.
It existed long ago. Right.
Yep.
Interesting. This is very, very good stuff. Not covered well in articles, blog posts, and even
because hackers don't like to talk about errors, but errors are there. I am pretty sure that other databases have this corruption stuff. Well, they have errors for sure. There is a whole lot of errors in MySQL, and sometimes they discuss it. There are corruption in MongoDB and other databases. And the question is, who is prepared to handle the problem? We have a lot of stuff. I'm not entirely sure that having a lot of stuff is a good thing, because like take this or take that, or it's emergency at the end of the day. You need
you heard about it something but never used, right? And you need to make decisions. It's difficult.
Yeah, we tried to do drills about corruption, like providing corrupted database and asking
Lisovsky has very good extension. Probably it should be extended further. Not extension, project. I don't remember the name, but its idea, it's like how's it called, Netflix project Monkey something, House Monkey, right? So the idea, let's make some harm to your Postgres and see what happens. And this is good exercise for non-production to be prepared better for future incidents.
Cool. So, I didn't use it.
Yeah, I will put name. I will tell you later and put name.
Do you write somewhere what to put? What links you are going to put there?
It will be under video. Links I have big to do now. I will put a lot of links in under video, but I'm not sure this project by Lisovsky deals with corruption anyhow. It's mostly for replication and so on. But I see it clearly that we need something to break your database as an exercise.
house monkey to do drills sounds like great. And maybe for interviews to hire new developers or SREs. Cool. That's all I have for today. Probably if you have some questions to discuss or something to add or something to correct. I think your mic is off, Nick.
Sorry about that. Right. It's the extension of project by Lisowski. It's called Noisia. Ham from workload generator for Postgres. So this ham from workload generator could probably also break a Postgres in terms of make it corrupted. I think it's a good idea to extend this project. I think I'm out of quota asking questions. I asked too much this time. And let's see if our chat has anything. Like we have a few seconds. If you want to ask something, please ask. If no, again, I encourage everyone ask questions in comments. We will be able to follow up. It was so great. I learned a lot, especially from the second talk. I didn't expect that I will learn something new, but I learned, definitely. Thank you so much. My personal thank you to you. And I hope these materials will be very helpful for all who deal with Postgres.
Yeah, I can share presentations, by the way.
Good. Yeah, I will include more links to comments and description below video. So I know it's late already at your place. Thank you so much, Andrey, for this. Everyone, please share, likes, subscribe, like, and share in your social networks and groups. It was great. Thank you. Have a good night.
Thank you very much. Goodbye.
Bye.